on the schedule, it said we'd get started right at 2. I'm going to delay things about 10 minutes just so that I can tell you guys a little bit about our summer app space, and then I'll just kind of eat into the reception at the end. So the presentations will start in 10 minutes. I'm going to spend the first 10 minutes talking to you about what it is that you're going to see presented and how these high school students made it to being research scientists here at Caltech. Summer App Space is a 6-week summer program run as an apprenticeship to teach high school students computer skills. We focus on the computer programming language Python, but also kind of the full end-to-end day-to-day work life that a typical software engineer or scientist might need to do interacting with computers. For our student selection, we publicized the application widely, and I went traveling to high school schools in the area, and we got over 120 applications, many of which are from low-income students. We did anonymous interviews. We gave anyone who applied the opportunity to interview. The application was very short, but the interview was rigorous. We did 15-minute interviews with students, asking them about their passions, and also doing a technical interview. And it wasn't that we only accepted students who had programming experience. That wasn't the case. We accepted a mix. But we wanted to see students' aptitude when faced with an unknown problem, or if they did have extensive programming experience, verify that. So we tried to admit about a third of our students, beginners, a third middle, and a third advanced, and the technical interview helped us be confident that those students were indeed in the bucket that they self-selected into, and that they had high aptitude for solving programming problems. So from that, we had a 10% selection rate, and we did the selections blind. So basically, we had ratings, and then we selected the top students independent of their demographics, of their background, of their age, and then we unblinded the applications, and we did do a few swaps in the end, but only of students with identical ratings. So we ended up with a extremely diverse class, which you'll see today in age, in programming experience, in interests, and that made for a very dynamic teaching environment as well. Because it wasn't the case that all students were at the same level or had the same expectations. Luckily, we had a very good student-teacher ratio, which I'll talk about in a little bit. So as I mentioned, the schedule was 6 weeks. For the first 4 weeks, we had the same schedule, and this was basically a boot camp preparing students to do final projects. We had 4 hours of lecture a week, 14 hours of lab per week, and 2 hours of guest speakers a week. And that was our Innovation Speaker Series, where we brought in entrepreneurs and scientists to speak to us. And we also sometimes took some time off in class to watch TED Talks, which was fun as well. So in the last 2 weeks, culminating in this day, which is our last day, our graduation day, it was all project work, teamwork. We divided into 3 teams. We brought in some high school teachers on board, 1 for each team. And again, these high school teachers had a variety of programming backgrounds. We had advanced teachers, we had teachers who had never seen code before. And we tried to match them with teams so that not only would the students learn from them, from their life experiences, but that they would learn from the students as well. We continued with our 2 hours of guest speakers a week in the Innovation Speaker Series, and we also had a few lab visits and had guest scientists come in and give us talks about their research. The curriculum, so there's a 70-page custom collaborative open source online textbook. There's 4 weeks of open source lab assignments, 16 hours of recorded lectures, open source lecture slides, and every week in the 4 weeks leading up, there was always a challenge capstone open-ended assignment for advanced students. So advanced learners who might be familiar with programming could come in, if they hadn't seen the Python programming language, brush up on Python and not tackle the basic exercises, but jump straight into these capstone exercises. We had super talented instructors. I'm not saying that just because I was one of them, but all our lab assistants had a PhD or are PhD students. All our lecturers have a PhD, and all the lecturers and lab assistants were volunteer. So thank you, Dr. Jamison Rollins, Dr. Carrie Nugent, Dr. Sebastian Kielman, Mike Grinish, and Ibuke Turker. Thank you. Ibuke Turker, I will talk about her role in a second. She was our learning scientist and was here for every single program day without fail, really helping us keep the program tight-knit. The first week we worked with satellite data from NASA. The second week we worked with solar data. The third week we actually worked with gravitational wave detections. These are high school students. LIGO data. And the fourth week we worked with galaxy and cosmology data. And each of these projects were already working with real-world data, but trying to learn various fundamentals of programming: Python, objects, variables, operators, control flow, functions, data structures, modules, API, problem solving, object-oriented programming, input and output, and version control, collaboration, the Bash console, testing, and some advanced Python. So it was definitely a boot camp, certainly an intense week. In our Innovation Speakers series, we had 2 talks per week, and all these talks are available online on YouTube. Here's a couple cool snapshots. We had Dr. Sean Carroll, who's a respected science communicator, but also a professor here at Caltech doing research on theoretical physics, come here and talk to us about his research. We had a future astronaut who's reporting for training next week at NASA come and talk to us. So all of these speeches were not just for the students, but also for me, an excuse to get these speakers in, and they're all recorded, and many of them have hundreds of hits already. So I promised to talk about Ibuke Turker's role. Learning scientist Ibuke Turker was present all programming days, and she helped us do breakouts with one-on-one live quizzes, interactive quizzes. She did 3 one-on-one interviews with every student throughout the course. She mediated daily learning journals for the students, and the high school teachers also came to self-study the curriculum and join us, giving us feedback. And we just had a final exam, and the results will be coming in an hour as to how they did. And today we have our final project presentation of the group work. So here's an example of a learning journal, and they did have the opportunity to post to public blogs, and those blogs will be released very shortly. The students also got financial awards. This was run as a paid apprenticeship, so students were paid minimum wage to join. The final project prizes today, configurable laptops running Linux, will be awarded to 4 students. Students were introduced early to the financial rewards of a career in technology. I think that a lot of times, at least growing up, I thought of a scientist as someone who either was rich or extremely selfless, and it is the case that the academic track isn't necessarily the most lucrative track out there, but it certainly is flexible and rewarding and intellectually stimulating, and the skills that you gain are so marketable that a variety of companies, if you choose not to apply your skills in academia, are willing to pay you 6-figure salaries to do this kind of work, which can be a lot of fun. So I think introducing students early on to this is hopefully going to be beneficial as they go ahead and choose their future career. The high school teachers were also paid to join, so we did have the chance, although all the mentors and the program instructors were volunteer, all the participants were paid. So here's the specification of the laptop. So now let's finally get to, I said about 10 minutes, the final projects and the demo day. So for the last 2 weeks, students have been working on final projects. Teams of 4 high school students, 1 high school teacher, working together as equals on a team. They were given open-ended problems without pat solutions, so real-world research. They did each have a mentor working in a research field that they could ask questions of, but it wasn't that their mentor even knew the answers to those questions. So it was the case that these students tackled extremely difficult problems on a tight timeline. They used concepts developed throughout the work, the coursework and developed student leadership, communication, teamwork, and technical ability. And we saw that a lot of the students went and took the kind of exercises that we had done throughout the course and the capstones and applied them and even learned them in more depth throughout these projects. So here we are at demo day, and we have a group of elite judges, one of whom is probably stuck in traffic. But we have 3 judges here. And to the Caltech community. Are you Max? Yes. Perfect. Come right up here in the hot seat. So, perfect timing, because I'm going to have you guys each say maybe a minute about yourself and your background.
Hi, everyone. I'm Yaron. You could pronounce it like you're on. Originally from Israel. Went to MIT, studied computer science, and while at MIT, I started also a program for Israeli and Palestinian youth to learn computer science, business, entrepreneurship, and we just finished our 14th summer in a row. After that, I went to work at Google for a few years as a product manager, started my own company called Red Beacon, which I sold, and am now working on another startup, and my day-to-day is very similar to what you guys are doing. I'm programming in Python and using the Django framework along with Swift to create an app. So really excited to see what you guys have.
Yeah, and I'm so pleased you could join us. I taught twice in the program that you founded and was very inspired by the work that you've done to do work here in the States, teaching kids how to code.
Hi, my name is Max Cantor, and I have a background in GIS and geography. And I've done a lot of work with water utilities, water systems, and the water grid. I've also started my own business, a startup called Saturate, and we work in sustainable land management practices using smart irrigation controllers and smart technology to manage land. So I'm excited to see what you guys got.
Hello, my name is Kelly Spears. I have a background in computer science. I've been doing development for over 15 years. Currently started with Java, currently doing mobile development in Swift for a Procore, which does cloud-based construction management software. So it's really nice to see such a diverse group of students that are interested in combining their love of all the sciences. So I'm really happy to be here and participate.
Hello, I'm Sarah Gavitt. I'm the Assistant Director for Engineering and Science at the Jet Propulsion Laboratory. I also went to MIT, which is probably, and majored in aeronautical and astronautical engineering. Probably the last time I actually coded was at MIT using Fortran 4. Number 4, which kind of dates me. After college, I went to Lockheed Martin, worked on the Magellan mission to Venus, and then I went to the JPL, where I've worked on missions to 3 other planets, the main asteroid belt, and astronomy mission, Kepler, looking for planets around other stars. And I think the closest thing I've done to writing software was I was the fall protection system engineer for the Cassini mission to Saturn, which is about ready to end its mission, diving through the rings of Saturn. And so I was looking at how to detect faults on the spacecraft and automatically write the software that would respond and call home. So I'm really excited to see what you've done and looking forward to it. Thank you.
All right. Can I invite up? Well, yeah, we can clap. Good idea. Thank you. And can I invite up Team Galactic Enterprise to the stage?